This video is about arc fault protection, specifically NEC 210.12, and how to pass the arc fault portion of your electrical inspection. You want to remember to always check with your local HJ, authority having jurisdiction, and your local and state adopted codes. References today are going to be taken from the 2023 NEC National Electric Code. If we go to Article 100 of the NEC, we see that arc fault circuit interruption defined is it's a device intended to provide protection from the effects of arc faults by recognizing characteristics unique to arcing and by functioning to de-energize or open the circuit when an arc fault is detected. Arc fault protection was first introduced in the 1999 NEC based on research that found that arc faults were one of the leading causes of residential fires. At that time, the Consumer Product Safety Commission recognized that at least 50% of those fires could have been prevented with some type of an arc fault protection device. It's estimated each year arc faults start more than 35,000 home fires, cause more than 1,000 injuries, 500 deaths, and $1.4 billion in property damage. One of two types of arc fault conditions tend to occur. One of them is the parallel fault. And if you look at the graphic that I have up here, a parallel fault can happen between line to neutral, line to ground, or neutral to ground. Because of some type of broken insulation or some type of a gap, you get a parallel arcing between those two locations. A series type fault is going to occur in the same conductor. And again, because of broken insulation or some type of damage to the wire, you're going to get a fault in series occurring at that location. NEC 210.12 tells us that arc fault interrupter protection must be provided in a certain number of ways. So if we look at A, the means of protection shall be provided by any of the following means. So A1 would be a listed combination type, and that's going to be important later. A listed combination type AFC installed to provide protection for the entire branch circuit would be one way of accomplishing that. Now, if we look at the first generation AFCI protection, that type of a breaker was called a branch circuit feeder AFCI breaker or AFCI overcurrent protection device. The breaker was permitted initially in the 99 code cycle. So if you look at this breaker that I have pictured here, and if we zero in on it a little bit closer, you'll see that it just states on the breaker itself, it's a branch feeder AFCI. That was the first generation AFCI that they required. Beginning with the 2005 NEC cycle, they then required that you install a combination type AFCI breaker. The original branch feeder type AFCI did detect both parallel and series faults, but it was limited on two-wire series faults. So the combination breaker was required, where both the combination AFCI breaker and the branch feeder AFCI breaker, both of them will pass a parallel arcing test and a series arcing test. The combination goes one step further and can pass the two-wire test for series arcing, and that was why the code now requires a combination type. So for something like lamp cord wire, that brown wire that's a two-conductor wire, they call it SP2 wire, or for some type of two-wire conductor, the combination AFCI will detect a fault in a two-wire conductor. Now you may be wondering why a thermomagnetic or our standard breaker doesn't pick this up. The reason is they found in testing, and they found it because of these house fires, that sporadic arcing is not picked up. So you don't get the current that you need to trip or open a standard breaker, which is why they came up with the arc faults. Now in existing installations, 210.12e begins to tell us like where do we need to add arc fault protection in an existing installation. And it talks about wiring extensions, modifications, replacements. So if the branch circuit wiring is modified, replaced, or extended more than 6 feet, it tells us that we're going to need to add arc fault protection. But there's other code sections that we have to look at to make sure that we're following what the NEC requirement is. So in the exception of E, we see that it's not required where the extension of the existing branch circuit conductors is not more than 6 feet and does not include any additional outlets or devices other than splicing devices. And this measurement, it doesn't include boxes or doesn't include the panel. But when I said if you look at other sections of the code, so we have to look at the code in its entirety. If we look at 406.4, number 4 of arc fault circuit interrupter protection, it talks about replacement of receptacles in required AFCI areas. So 406.4 tells us that if a receptacle located in any areas specified in 210.12a, b, or c is replaced, a replacement receptacle at this outlet shall be one of the following. And that goes on to tell us a listed outlet branch circuit type AFCI receptacle, a receptacle protected by a listed outlet branch circuit type AFCI, a receptacle protected by a listed combination type AFCI circuit breaker. Okay, and this is where the code kind of gets a little bit gray. So if we look at 210.12a2, a listed branch feeder type AFCI, so we talked about that earlier and I have it pictured here, installed at the beginning of the branch circuit in combination with a listed outlet branch type AFCI installed on the branch circuit at the first outlet box. And then it goes on to say that you have to mark that first outlet box. So that would be one way that the code is telling us that we can protect this circuit. Another way is in 210a3, a listed supplemental arc protection circuit breaker installed at the origin of the branch circuit in combination with a listed outlet branch circuit type AFCI installed on the branch circuit at the first outlet box if all the following conditions are met. And then A4 goes on to tell us a listed outlet branch circuit type AFCI installed on the branch circuit at the first outlet in combination with a listed branch circuit overcurrent protected device if all the following conditions are met. And you can go to 210.12 and A3, A4 and look at this yourself as far as the additional conditions that need to be met. So as I said, this seems to be a gray area in the NEC because it doesn't appear that there are listed OCPDs, branch circuit feeders listed to be used in combination with other devices. So it seems like the code is stating that they want something that would be able to be used together in combination, both of them being listed to be used together. And as far as I know, there isn't anything that exists at this time. If somebody does know of something that exists, please put it in the comments with a link so that other people can find it. But I think that this was something that was put in the code and there isn't any type of listed devices at this time that can be used together. So if you look at some of the listed devices that they talk about, the branch feeder type, which I have up on the slide right now, that's your standard thermomagnetic, but it also does do series and parallel arcs, but not all series arcs as we talked about before. So you would need something else that would pick up those two conductor cords, two conductor wires assemblies for that series arc. The combination type is the type that now is required since 2005, and that is the one that picks up all parallel, all series arcs. And as far as the supplemental, I'm not aware of a supplemental arc fault protection device. If somebody is, again, put it in the comments so that, and with a link so that other people can find it, but I do not think that that exists, or I'm not aware of one of those existing. Now they do make AFCI receptacles, and it's something that you can easily find. It does appear that 210.12a5 is one of the ways that you could accomplish protecting the circuit using the AFCI receptacle. In A5, it states that if it's a metal raceway, so EMT, rigid heavy wall, or IMC, metal wireways, metal auxiliary gutters, type MC or AC cable, meeting the applicable requirements of 250.118, which is basically the grounding requirements, they state that you can use that between your first outlet, if that was the start of the first outlet, to protect all the other devices that are on that outlet. Now in 210.12a6, the code gives a final solution possibly where you might be able to provide AFCI protection, where you have a listed metal or non-metallic electrical PVC or type MC cable. It seems somewhat impractical, but if you had to do this, if it was buried in 2 inches or more of concrete, then they would allow you between that and your first AFCI protection. It's important to remember, though, that the branch circuit that's upstream from this, as an example, if you're using an AFCI receptacle at the first outlet, anything upstream is not going to be protected, so it's not protected against any type of an arc fault. Now, if we look at Article 210.12b, this tells us where that protection is required. So all 120-volt branch circuit supplying outlets, and I'm highlighting outlets there because we'll talk about that in a minute, in kitchens, family rooms, dining rooms, living rooms, bedrooms, laundry areas, hallways, closets, and similar areas, and then also in dormitory units, they all require AFCI protection. And something that's brought up often in inspections is, does the smokes need to be protected, smoke detectors and CO detectors. And yes, if they're going in those areas, anything that are in those areas that require protection, they are going to have to be protected by an AFCI protection device. And the reason that I highlighted outlet is because if, again, you go to Article 100, and that's a good place always to go to in the NEC to determine how they're defining different terms in the NEC. So if we look at outlet, it's a point on the wiring system at which current is taken to supply utilization equipment. So if you look at this picture in the slide, that is an outlet. Anything that wires are coming out of are an outlet. Oftentimes guys think an outlet is a receptacle, and where a receptacle may be installed in an outlet or is installed in an outlet, it is not called an outlet. A receptacle is a receptacle. So utilization equipment is equipment that utilizes electrical energy for electronic, electromechanical, chemical, heating, lighting, or similar purposes. So that would be equipment that's coming out of the outlet. Receptacle outlet is an outlet where one or more receptacles are installed. So when you look at that code, you have to look at, it's not saying receptacles, and often on inspections, electricians will say, I thought it was just the receptacles, and it isn't. So the kitchen 120 volt, 15 and 20 amp outlets all need to be arc fault protected. So that's everything in the kitchen needs to be arc fault protected. So it's important that you look at how do you meet the code by the definition of an outlet. And then another point to consider, as we were talking about in existing installations, when you're trying to protect the circuit and using that receptacle, that AFCI receptacle, again, don't confuse outlet with receptacle. So if you're trying to protect a kitchen with the receptacle, the AFCI receptacle, and you meet the EMT requirements or you meet the metal conduit requirements, you have to consider that you're going to need to protect that whole circuit, which is going to be somewhat impractical. If you're trying to protect the bedroom, it might become more practical. But again, you have to remember, go back to the code, look at Article 100, and remember to always identify their definition of what an outlet is, what a receptacle is. And just to give you a little summary of the history of changes, 2017 was where they really expanded the arc fault requirements, and it was basically living areas. And if it's an area that's considered a living space, that was an area that needed arc fault protection. In 2020 was where they expanded to include dormitory units, and they made it a little bit clearer. And then they also talked about replacements and retrofits. So they made it more clear on if you're replacing or retroing out an AFCI required location. 23 clarified AFCI applications a little bit better for alterations and upgrades. So there wasn't any new code, but there were some clarifications where they added some code language. The 2023 code also gave you the specific 14 room areas. So they put that in a list, which made it clearer and easier. And they titled it dwelling units. The other thing I want to bring up with these type breakers is that there has been some confusion at different times on inspections where electricians have thought that they're putting in a dual function, AFCI, GFCI. A combination is the type breaker that picks up parallel and series faults, as we talked about. A dual function, or as this breaker here says, all-in-one breaker, where they list that it's AFCI and GFCI protection. There's a big difference there. So in the beginning, it was probably more of an issue, but I still run into it every now and then where an electrician will put a combo in a combination breaker and think, because it states that on the breaker itself, that it's GFCI and AFCI protection, and it is not. It either has to be dual purpose or it has to list, as this one does, somewhere on their AFCI, GFCI protection in order for it to be protecting both of those faults. Okay, so to sum it up, Article 210.12 is the article all about AFCI protection. It's required for all 15 amp and 20 amp 120 volt branch circuits supplying outlets, as we discussed, in kitchens, family rooms, dining rooms, living rooms, bedrooms, laundry areas, hallways, closets, or similar areas. So similar living spaces, you need to protect it with AFCI protection, and also in dormitory units as required in that section of the code. Okay, so I hope that this information will help you pass your next arc fault portion of your electrical inspection. If you liked the video, remember to subscribe and give me a thumbs up, and let me know in the comments if there's other videos you'd like to see me do. And thanks for watching.